Restricted ideal pseudo-intuitionistic sets. We introduced them in this video. I described them in my recent paper for Asia Mathematica, and the idea is to generalize Choker's concept of intuitionistic sets and to combine this concept with weak rough sets that are known as nested or double sets too. So we obtain a new class of objects that can be considered as non-classical sets, and they have certain connections with, say for example, neutrosophic crisp sets and picture sets, but our concept is slightly more flexible. First, let us recall the idea of ideal. An ideal I on X on a non-empty universe is any non-empty family that is closed under subsets, as you can read in this line, and that is closed under unions. And if the whole universe does not belong to our ideal, then we say that it's proper. Besides, we can see that empty set belongs to any ideal, so its singleton is an ideal too, and moreover it's visible that every ideal is closed under intersections, because if we have two sets that belong to the ideal I, then of course their intersection is a subset of A, so because of the closure of subsets, under subsets, this intersection belongs to the ideal too. Now, the crucial definition. Suppose that X is a non-empty universe of objects and assume that we have some ideal on X. And assume that we have three subsets of X. AT stands for truth, AF stands for falsity, and XA. XA is a kind of relativist universe, smaller universe that we are interested in. And there are three subsets of X such that AT, its union with AF, is contained in XA, and moreover, their intersection, the intersection of truth and falsity, belongs to the ideal. Then we shall call this ordered triple AT-AF-XA. We shall call it restricted ideal pseudo-intuitionistic set on X. RIPI set, we can say for brevity, RIPI. Okay. We can define several algebraic operations. And the first two are rather standard and modeled after Choker's intuitionistic sets. So when it comes to intersection, we have intersection of truth sets and union of falsities, and then union of this relativist smaller universes. As for the standard union, we have union of truths and intersection of falsities and union of XA and XB. Then we have strong intersection. Here we have two intersections of both truth and falsity, and union here, and strict intersection. Here we have three intersections. Okay, we used different symbols here. One can easily prove, you can check this proof, that these operations produce new RIPI sets. Okay, so here we checked intersection. Please analyze the proof, it's not difficult. Yes, we need to check two things: that the intersection of our new truth components belongs to the ideal, and that the union of our new truth and new falsity component is contained in the union of XA and XB. As for the complement, it's defined again, modeled after the idea of Choker. It's defined in the following manner: AC is and replace truth with falsity and falsity with truth, and we have the same relativist universe XA. Okay. We have several distinguished special sets. Universal set, as you can see, it means that all elements of universe are evaluated, so our relativist universe is X, and all of them are accepted. So again, the truth set is X, while the falsity set is empty. Empty set is here. Again, all the elements are evaluated and none are accepted or are rejected. Indeterminate set, we evaluate everything, but we do not feel able to say that some of these elements are true while the other are false, so we have two empty sets here. And indifference set, we refuse to evaluate anything, and of course we refuse to classify any elements. Okay. So we have two or three inclusions. As you can see here, truth contained in truth, falsity of B contained in falsity of A, so here the order is reversed, and XA contained in XB. Strongly contained if the following idea holds, as you can see here, and strictly contained. Okay. And then these orderings are introduced in the following sense, is that A is contained in B if and only if A and B is equal to A. I'm not sure, you should check in my original paper. It seems that here perhaps it's a mistake. We should have XB contained in XA, yes, to obtain these properties that are listed here. Okay. And we can prove several properties like commutativity, associativity, absorption laws, distributivity laws, De Morgan laws, and double negation law. So we obtain the Morgan algebra with these standard operators, yes, intersection and union and the standard manner. Moreover, we have following properties that, for example, a complement of universe is empty, the complement of empty set is the whole universe, that the addition of universe gives us universe, that the intersection with universe gives us A, and so on and so on. But moreover, we have several properties that refer to our other distinguished sets, and they are listed here. So as we said, we have De Morgan algebra with our standard operators, but it's not Boolean. You can easily find counterexamples, and in fact they are in my paper for the law of the excluded middle and for the law of consistency of non-contradiction. Yes, they do not necessarily hold. We can define the difference, we could say standard difference, by means of standard intersection, and one can check that the following identity, which is true in classical sets, it's no longer true in this framework, but it's not true in the framework of fuzzy or intuitionistic fuzzy sets too. Okay. As for the non-standard operators, they're commutative, associative, idempotent. This is obvious. Okay, but we have also several other properties that are listed here. It wouldn't be reasonable to read them all, but you can check if they are true, and moreover you can think about their meaning, yes, and the logical or maybe even philosophical sense. The following properties of distributivity hold. You can see that, for example, standard union with strong intersection, yes, its distributivity goes in this way. Okay, and moreover, for strict intersection, we have those properties listed here. Again, several versions of distributivity. And that's all, but in my paper, which is listed here, Restricted Ideal Pseudo-Intuitionistic Sets, published in August 2025, you can read more, some interpretations, comparisons, proofs, examples, counterexamples, and other ideas. So I encourage you, and moreover, you should know this seminal papers by Choker, yes, about intuitionistic sets and topological spaces. Moreover, it would be good to check my paper about triple sets too. Thank you very much for your attention.